What's up guys, welcome back to the channel. Today on this video, as you can see here on your screen, we have a national certificate mathematics N5, which was actually written on the 27 March 2026, and this was an X paper which took 3 hours to be written. So we'll be doing question 1, question 2, question 3, question 4, question 5, and question 6. So before we continue with this question, we're gonna leave the timestamps on this video just in case you don't want to watch this video in a sequence order. So we're gonna start with question 1, and then we're gonna do other question later on. So before we start with question 1, I just like to say thank you very much guys for watching, subscribing to the channel, commenting, and not forgetting those who like the video. If you haven't subscribed, subscribe to the channel because I've made videos on N5 mathematics, N3, N4 as well. So go to the playlist and check them out. All right people, let's look at question 1 and let's solve it. All right, so here is our question 1. As you can see, question 1, it has 1.1 and 1.2, with 1.1 having two sub questions there. So we're going to start with 1.1 and then we're going to do 1.2 later on. So let me just create space so that we can do 1.1. Here is our 1.1, guys. Let's look at this question and let's try to solve it. So we are given the following: log y with base 3 is equaling to limit x approaches 0. On the numerator we have 1 minus cos squared x. On the denominator we have x squared. Now we have 1.1 as the question. They want us here to determine the following limit with the same expression that is given to us there. Before you do any method to calculate the limit, you first start with the first method, which is direct substitution. Basically what you're doing here, you're gonna substitute your x with 0 since our x here is approaching 0. So let's do it. So we have to write log base 3 y, which is equaling to 1 minus cos squared 0 divide by 0 squared. Remember, we substitute 0 wherever there is x. So we're going to have 1 minus cos 0, guys, it's 0. So 0 squared divided by 0. Then, so at the end of the day, this here is going to give us infinity. So if this gives us infinity, we can use the L'Hopital method because we also have the fraction here and the direct substitution give us infinity. So these two criteria, they actually allow us to use the L'Hopital's method. With the L'Hopital's method, you first have to derive all the terms on the numerator and the terms on the denominator. Let's start. We're going to have log 3y, and then we derive the first term on the numerator, which is 1. So 1 is actually 0 when we derive it. Now we have minus them. The second term we have cos squared x. So we have to derive that cos squared x. This is a chain rule, guys. So when we derive that cos squared x, we're going to have 2 cos x multiplied by the derivative of cos. We know that is negative sine x. There we go. Divide by. On the denominator, we have x squared. So the derivative of x squared is going to be 2x. Then from here, let's just simplify it because we have a lot of negatives there. Negative 2 cos x multiplied by negative sine, that is going to give us 2 sine x multiplied by cos x divided by 2x, right? So we can also change this on the numerator. This is a double angle identity, which is actually sine 2x divided by 2x. There we go. So from here, we can also do direct substitution. So let's do direct substitution. So wherever there's x, again, we're going to substitute with 0. So we're going to write sine 2 multiplied by 0 divided by 2 multiplied by 0. This here is going to give us, let me zoom down a bit, 0 over 0, which in turn, this is actually infinity. So this means that we have to continue and use the L'Hopital method. Now, meaning we have to derive this part here, or you can derive from here. It really doesn't matter, but I think this one is way much better. Okay, so let's continue. Now we still have log base 3y, and then we can write, let me just continue, write limit x approaches 0, and then we have sine 2x divided by 2x. Now let's derive sine 2x. So if we derive sine 2x, first of all, the derivative of sine, it's cos, and then we have the coefficient of x, which is 2. So this is going to be 2 cos 2x divided by, now let's derive 2x. The derivative of 2x is going to be 2. So 2 and 2, when they divide each other, they're going to give you 1. So you're only left with cos 2x, right? Remember, our x is approaching 0. So wherever there is x now, we can substitute with 0. So you're going to have cos 2 multiplied by 0. And this here is going to give us 1. So our limit, guys, is actually 1. So I hope you guys managed to understand this one. Really, you need to know how to do the L'Hopital's method. If you don't know how to do the L'Hopital method, then this question was going to be a bit challenging for you. Just in case, guys, you want to know about this double angle identity that I use here, I'll leave a video on the description that explains these double angle identities as well on the description, and the very same video will pop up on the top right of the video that you're watching. All right, guys, we are done with 1.1.1. Let's look at the next question, which is 1.1.2. Let's look at 1.1.2. This is our question there. They say find the value of y. So remember, we are given the following: log base 3y, right? And then we're supposed to find the limit. So we just find out that the limit is actually 1. So here we just have to solve for y. You can use this law of changing from log to exponent. So the base here, it's a, and then this x is going to be the exponent, and this b is actually the answer there. So this law is used to change from log to exponent. I hope you know about this. This is entry work. So the base here is 3, and then the exponent is 1, and the y is the answer. Basically, y is actually equaling to 3. There we go. Right, people, we are done with this question 1.1.2. It was not that difficult. All you needed to know is the log laws. Just in case you did not understand, do not forget to go to the point where you got lost and try to rewatch from that point. If you manage to understand, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. We are finished with 1.1. Let's look at 1.2. Here is our 1.2. Now 1.2, it goes like this: determine the interval of which f of x is continuous if f of x is equal to sine x divided by x plus 3. So as you can see, our function here is a fraction. In order for us to find the values or the intervals for f of x to be continuous, we first need to find the values where it is discontinuous. So in order for this function to be discontinuous, it should be in this manner. It should be sine x divided by 0. That will give us infinity or undefined. So when a function is divided by 0, just know that whatever the value that causes us to have 0 there is the value where the function is discontinuous. So let's first find the value where f of x is going to be discontinuous. So what you should do here is you take your denominator, which is x plus 3, and then you equate it to 0, right? So you solve for x. So if you solve for x, you're going to transpose that 3 to the next side. That is going to be x is equaling to -3. So we can say this function is discontinuous when x is -3. So with this information, we can say f of x is continuous for all real numbers except -3. So we can say f of x is continuous for all real numbers except -3, because when x is -3, our function is going to be discontinuous. Except for that, our f of x is gonna be continuous for all real numbers. I hope you guys managed to understand this. It was not really that difficult. I guess maybe the statement it was gonna be the one that is challenging for you. But if you did not understand, please leave a comment in the comment section. I'll try to answer it to my level best. And always rewatch at the point where you got confused as well. Hopefully that will help you too. But if you manage to understand this, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. We are done with question one of this question paper. I hope you guys, when you subscribe, you hit the bell notification so that whenever I upload the next video, you'll be notified. Thank you very much, guys, for watching. Till next time, cheers.